All right, well, we're at our bottom of the hour, so I think we should get started. We have a lot to cover, I think. So good afternoon and good morning, everybody. Happy World Oceans Day, and welcome to our virtual session on the Endangered Species Act at 50, working toward resilient, endangered, and threatened species. My name is Dori, and I'm a climate specialist with the NOAA Fisheries Office of Protected Resources, and I'm going to be your moderator for today's session. Rachel, can you go to the next slide, please? Before we begin, I'd like to provide a few reminders on how to engage during our session. First, please do mute yourself throughout today's session unless you've been called upon during the question and answer portion. That said, please do feel free to type any of your questions into the chat at any time, and we'll get to those during the question and answer section at the end of all the presentations. Alternatively, if you prefer, when we get to that time for questions, please go ahead and raise your hand and I will call on you for you to be able to ask your question to the panelists. Finally, we'd like to remind you that today's session is being recorded and will be made available on the CHOW platform shortly after we end today. Next slide, please. Today, we're going to hear from three panelists. Angela Somma, the Chief of the Endangered Species Division in NOAA Fisheries Office of Protected Resources, will be leading us off with a brief history of the ESA and how climate change is being addressed under its mandate. We'll then hear about two examples. The first will be a brief presentation about corals under the ESA, provided to us by Jennifer Koss, the Director of the Coral Reef Conservation Program within NOAA's Ocean Service. We'll follow that with a presentation by Dr. Melissa Neuman, an Endangered Species Recovery Coordinator with NOAA Fisheries Protected Resource Division. Dr. Neuman will share with us some of the activities underway for white abalone found along the west coast of the United States. Once we finish the presentations, we'll move to our question and answer session, and then end with some closing remarks, again given by Angela Somma. So with that, and without any further ado, welcome everyone, and let me pass the mic to our first speaker. Angie, go ahead.
Thank you, Dori, and thank you everyone for joining us today. Next slide, please. I'm going to start out with a brief history of the Endangered Species Act. Federal protection of endangered species dates back to the Lacey Act of 1900, which was the first statute that prohibited interstate commerce of animals that were killed illegally. And then it wasn't until the 1960s where more attention was put on endangered species, and the Department of the Interior formed a committee on rare and endangered wildlife species to identify species in immediate danger of extinction. They created the Red Book on Rare and Endangered Fish and Wildlife of the United States that was published in 1964, and that served as the first official document listing species that the federal government considered to be in danger of extinction. 63 species were included on that first list. Next slide, please. In 1966, 2 years after the Red Book list was published, Congress passed the Endangered Species Protection Act. It was the first piece of comprehensive endangered species legislation. Its goal was to conserve, protect, restore, propagate certain native fish and wildlife. So it was limited to native fish and wildlife. That under the 1966 Endangered Species Act, the very first official list of threatened endangered species was created and was published in the Federal Register. That was published in 1967, and the list had expanded from the 1964 list and included 78 species, including short-nosed sturgeon, which is a species under NIMS jurisdiction and remains listed as an endangered species to this day. The 1966 Endangered Species, the 1969 Endangered Species Conservation Act provided protection of species in danger of extinction worldwide and prohibited their import and subsequent sale in the United States. The 1966 legislation was fairly limited in scope, and so in 1969, Congress expanded the act. And it expanded it to include species outside of the United States as well as native fish and wildlife. Among the first species that were added to this expanded Endangered Species Act were the eight of the great whale species, and many of those still remain listed on the Endangered Species Act to this day as well. The 1969 Endangered Species Conservation Act, I apologize for the typo I have in this slide, also called for an international meeting to adopt a convention to conserve endangered species. Next slide. And that convention was the Convention on International Trade in Endangered Species of Wild Fauna and Flora, otherwise known as CITES. And in 1973, negotiation of that convention concluded in Washington, D.C. when 80 nations signed the CITES Convention. CITES also turned 50 this year in March, and there are now 183 parties to CITES. CITES monitors, regulates, and in some cases prohibits international trade in species of plants and animals that are listed in its appendices and are considered to be harmed by trade. Following the conclusion of the CITES Convention, later that year in December, Congress passed the Endangered Species Act of 1973, which is still the act we work under today. President Nixon signed it on December 28th, following its passage unanimously in the Senate and by a vote of 355 to 4 in the House of Representatives. So even though it passed with very little opposition over the years, it has become a contentious, controversial, and litigious law that no longer shares that kind of bipartisan support. Next slide, please. The ESA of 1973 is the most comprehensive endangered species legislation that's ever been passed. And President Nixon said at the time that he signed the legislation that nothing is more priceless and more worthy of preservation than the rich array of animal life which our country has been blessed. The ESA has been amended several times since 1973, but its basic programs remain intact and the law itself has changed very little since 1973. There have not been any major amendments since the 1980s, and it hasn't even been reauthorized since 1992. Again, because it has become so controversial, there's been no consensus in Congress on any potential changes to the act. Next slide, please. The purpose of the Endangered Species Act is to provide a means whereby the ecosystems upon which endangered and threatened species depend may be conserved. So it was groundbreaking in that it protected not only species, but their habitats as well. And it also set a policy that all federal departments and agencies shall conserve endangered and threatened species and utilize their authorities to further the purposes of the act. So the responsibility for the Endangered Species Act lies not just with the two agencies who actively implement it, but put responsibility on all federal agencies to use their authorities to protect and conserve endangered species. Next slide, please. The ESA is jointly administered by the National Marine Fisheries Service and the U.S. Fish and Wildlife Service. We share responsibility for it. Generally, Fish and Wildlife Service manages terrestrial and freshwater species, while NMFS manages marine and anadromous species, although the Fish and Wildlife Service does have jurisdiction for a couple of marine mammals. In terms of the number of species that NMFS is responsible for under the ESA, there are 98 domestic and 65 foreign listed species. The total list of endangered and threatened species is over 2,000 species. So as you can see, the Fish and Wildlife Service has the majority of the species that are listed. NMFS has 11 candidate species currently, which means we're actively looking at those species and assessing their status to determine whether they should be added to the official list of threatened or endangered species. And there are some species for which we share jurisdiction and jointly implement the ESA for with the Fish and Wildlife Service, and that's marine turtles, Gulf sturgeon, and Atlantic salmon. Next slide, please. There's a whole variety of taxa now that are listed under the Endangered Species Act for which NMFS has responsibility. In the early days of the ESA, NMFS's species were largely marine mammals and sea turtles, although, as I mentioned earlier, short-nosed sturgeon have been listed since the very beginning. But beginning in the 1990s, NMFS started listing a number of fish species, particularly Pacific salmon. And now we have a wide variety of fish, shark species, as well as corals and invertebrates. And you are going to be hearing about corals and abalone, one of those invertebrates, further on in this presentation. Next slide, please. So the first step of receiving the protections of the Act is to get added to the official list. And we can either do that, either Fish and Wildlife Service or NIMS can initiate a review of a species we're concerned about, or the ESA provides the opportunity for any individual or organization to petition us to list a species. And once we've received a petition, then the Act sets out very strict deadlines for which we have to respond to that petition. If we do find that the petition may be warranted, then we initiate a scientific status review where we evaluate the status of the species, the risk of extinction, as well as the threats facing the species to determine whether it meets the definition of a threatened or endangered species. And if it does, we are required to list the species. We must make listing decisions based solely on the best available scientific and commercial data. We're not allowed to factor in any other considerations than the best available scientific and commercial data. Next slide, please. Once a species is listed, we designate critical habitat for that species, and that is to be designated at the time of listing. If we can't determine that at the time of listing, that can be extended for 1 year. Critical habitat can include areas that the species occupies, but it can also include areas that it either no longer occupies or never did occupy, but which will be essential to the recovery of that species. And that may become critical as more and more species are affected by climate change. Unlike listing decisions, we can consider economic or other impacts in the designation of critical habitat and can exclude areas based on those impacts if the benefits of exclusion outweigh the benefits of inclusion. But it's not unlimited, and we cannot exclude any area if it would result in the extinction of the species. Once critical habitat is designated, there are restrictions on how federal agencies can conduct their activities within that designated critical habitat. Next slide, please. So the goal of the Endangered Species Act is not just to prevent the extinction of species, but also to recover them to the point at which they're no longer at risk of extinction and no longer need the protections of the Act. The ESA directs us to develop recovery plans for listed species, which we do typically in partnership with states, tribes, and conservation organizations, academics, and other partners. These recovery plans are roadmaps that identify the actions that will need to happen in order for the species to recover, the threats that will have to be addressed, and the criteria, the objective criteria for when we will know that the species is recovered. And then we work cooperatively with our partners in implementing those recovery plans. We also conduct interagency consultations, which I'm going to discuss in a minute, and provide recovery grants to states and to academics to conduct research and engage in recovery activities. Next slide, please. The ESA envisions a strong role of states in species recovery, and there is a section 6, that deals with cooperation with states, in which NOAA Fisheries and Fish and Wildlife Service enter into formal conservation partnerships with the states through Section 6 agreements once we've concluded that those states maintain active and adequate endangered species programs. And once those agreements are executed, then those states become eligible to receive funding through our Species Recovery Grant Program to support recovery activities. And that grant program, ours is small in comparison to the Fish and Wildlife Service, but it is currently funded at about $7 million a year. And most of those funds go to the states. A portion of the Species Recovery Grant Program also go to tribes who we work cooperatively with to recover our species. Next slide, please. Section 7 is the interagency consultation provision of the Act, and it is often described as the heart of the ESA. This is where a lot of the teeth to the ESA reside, this in Section 9, which I will cover in a minute. Section 7 requires all federal agencies to ensure that any action they authorize, fund, or carry out is not likely to jeopardize the continued existence of a listed species or destroy or adversely modify its critical habitat. And any federal action that may affect a listed species, no matter to what degree, it requires that that federal agency consult with either us or the Fish and Wildlife Service, depending on the species. This directive has been the single most significant provision of the ESA, particularly after the Supreme Court determined in 1978 in TVA v. Hill that Congress's intent in the Endangered Species Act was to, quote, halt and reverse the trend of species extinction, whatever the cost. Next slide, please. The other major protection that species receive once they are listed is in Section 9, which is the prohibition section of the ESA. This applies automatically to endangered species. For threatened species, they can also be applied through regulation if we determine that that would be appropriate for a threatened species. The ESA defines take very broadly, and it prohibits any individual, any entity, any corporation and government entity, anyone under the jurisdiction of the United States from taking an endangered species without a permitted exemption. And take is defined very broadly. It's not just to intentionally injure, wound, or kill a species, but it includes unintentional actions, it includes harassment and harm, or even an attempt to engage in any such conduct. So it's a really sweeping definition of take. Next slide, please. There are some exceptions, however, to those take prohibitions that allow us to permit important scientific research and survival and enhancement activities. There is also provision in Section 10 that Section 7 covers federal agencies for non-federal entities who are engaged in an otherwise lawful activity, who may unintentionally take a species. There is a process for them to receive an exemption if they develop an improved conservation plan with us and that they have minimized and mitigated that incidental take to the maximum extent practicable. There's also an exemption for Alaska Native subsistence use in the ESA. Next slide, please. So since the theme of CHOW this year is climate change, I'm going to talk a little bit about how we have been dealing with climate change in the implementation of the ESA. And there has been a fair amount of litigation in this area, and courts have affirmed the importance of considering climate change in our determinations and decisions under the ESA, despite the uncertainty that may exist in terms of what the impacts of climate change may be. Next slide, please. So the National Marine Fisheries Service was the first of the two agencies to list species based on climate change being a threat to the species in 2006. We listed the elkhorn and staghorn corals as threatened species. The Fish and Wildlife Service followed in 2008 when it listed the polar bear as a threatened species. And in the 2010s, NMFS listed several species of ice seals as threatened species. We have continued to receive, and as has the Fish and Wildlife Service, a lot of petitions for species that are impacted by climate change, with that as being the major threat. So that continues to be a big area in our listing program, is assessing impacts of climate change on species. Next slide, please. The listing isn't the only area where we address climate change, and we do incorporate climate change considerations into our ESA assessments and decisions, in our recovery plans, in our Section 7 consultations, and in our Section 10 incidental take permits with non-federal entities. Many of those Section 10 permits have a very long lifespan. They can range from 25 to 50 years. So it's really important that we account for potential climate change considerations in those permitting actions. Next slide, please. To help our agency biologists address and incorporate climate change considerations, NMFS adopted National ESA Climate Guidance to provide greater consistency in our ESA decisions and to help us make scientifically defensible ESA-related management decisions in light of climate change. We first issued this in 2015, and we just recently updated it in May of this year to incorporate new information since 2015, including the IPCC's 6th assessment report. Our climate change guidance identifies 6 key climate change considerations that the guidance addresses. And in terms of the first consideration of selecting a climate change scenario, this comes into effect most frequently with listing decisions. And our guidance says that for ESA decisions involving species impacted by climate change, we will use climate indicator values projected under IPCC's SSP 3 7.0 when data are available. This was a slight update based on the new IPCC assessments. In terms of selecting a climate change projection timeframe, we do, when we predict future status of species under decisions that we make, not just under listing, but under Section 7 consultations and Section 10 permitting, we project those climate change effects for the longest period of time over which we can reasonably foresee those effects. Next slide, please. The ESA does more than just incorporate considerations of climate change in its decisions and implementation. It really can provide the protections for the species to address all the threats facing it so that we can build resilient populations to be able to withstand some of the effects of climate change. And adaptive management is really key for listed species in the face of climate change. And when we can, in our consultations and our permits that are going to occur over a long period of time, we make sure that we build adaptive management into those permits and consultations that include things like adequate monitoring of climate and biological variables, identification of appropriate triggers that will make us reassess the conclusions and decisions that we've made, and identification of protective measures that we can implement without having to reassess everything. Next slide, please. And I would just conclude by saying that the ESA at 50, it's an extraordinary law that has prevented the extinction of 99% of the species that have been listed under it, and has recovered a number of species and has put many more on the path to recovery. It's still the most comprehensive endangered species legislation that we have. And although the nature of some of the threats facing the species may have changed, when Congress passed the ESA in 1973, they were not really thinking of climate change, but it's still as relevant to species conservation now as it was 50 years ago. And thank you.
Thanks, Angie. Let's switch over to Jennifer.
Thanks, and thank you, Angie, for the great setup. A lot that I don't have to go through now, and you articulate it much better than I do. So why corals under the ESA in terms of what is the importance? What are we trying to conserve and recover? So coral reefs protect coastlines from storms and erosion, provide jobs for local communities, and offer opportunities for recreation. They're a primary source of protein for a lot of Pacific Island nations and other areas around the world, and have huge economic potential in terms of biopharmaceuticals that have yet to be tapped into. Over 500 million people directly depend on coral reefs for food, income, and protection. Fishing, diving, and snorkeling on and near reefs add hundreds of millions of jobs and dollars to local economies. And I think overall, the conventional wisdom is that we're valuing corals in the tens of billions of dollars when you're just looking at economic income. But when you add the protective values of coral reefs to coastal infrastructure, we're up into the trillions. And on top of anything economic, they're incredibly valuable for the cultural reasons and indigenous populations who happen to live on a lot of island areas. So next slide, please. Corals right now, we've got 25 listed species. And you can see the range of when that happened. So in 2006, I think Angie articulated that was that first listing of acroporids then. And since then, we've had additional species listed, with the last one being in 2015, where interestingly enough, a species was delisted, and I had to go back to our protected resources folks and find out what that was. And that was a Siderastria species that interestingly had been a Caribbean species that somebody planted in the Pacific, and then it was thought it was a native Pacific species. So this feeds into sort of the questions and conundrums around listing corals in terms of what corals themselves are. So right now there are over 6,000 species of anthozoans. That's the classification that corals fit into. And of those 6,000 species, roughly 1,500 are these stony or scleractinian corals that are your reef building species, so critical to island nations and coastlines like Florida and Hawaii. So we've got 25 listed species. I already mentioned that. And if we could go to the next slide, I'll get into a little bit of the conservation challenges. I long have wondered if the original authors of ESA really thought about listing invertebrate sessile marine species that are equal parts animal, mineral, and plant, and largely understood. As simple as that sounds, they're not terribly well understood at this point in time. Just in figuring out what species corals are, most of the taxonomy was done by observation and morphology. And you can have the same species of coral in a 4 reef area that gets a lot of wave energy, and then take the same species in a back reef calmer area, and they will look drastically different, but they're the same species because they've adapted to the wave energy and biological conditions of the environment that they live in. So there's a lot of controversy over species identification itself. And then when the petitions to listing happened, we don't have a lot of genetic information on many coral species. We're just now getting to the point where we're mapping them. And we didn't have a lot of baseline understanding of population ranges and what would have been a normal population of these corals prior to the impacts of climate change. So that made just the listing process itself difficult. On top of that, we've now said climate change is the #1 threat to corals worldwide, yet NOAA and Fish and Wildlife don't regulate carbon dioxide emissions. It's not within our mandate, not within our purview. So it's really hard if you're trying to deal with the #1 threat to a species to abate for that. So we're working around the impacts of climate change, and those are largely warming waters for corals and more acidified conditions in that corals are existing in. So warming waters tend to cause corals to bleach, which can lead to mortality. And then more acidified waters just makes it hard for corals to do their job in building their own skeletons and keeping their life cycles going. And the one last thing I wanted to say there is that to delist a species, you would have had to recover it throughout its species range. Coral species exist in US waters and then many international areas as well. So again, as a federal agency, you really can only affect change in your own waters and then work as proactively as you possibly can with other nations so that they're doing the same types of conservation activities that you are if we're going to get to the point to being able to delist. Next slide. So even with all that doom and gloom, there's a lot of bright spots happening. NOAA Fisheries, they're protected resources folks. They are the ones responsible for implementing ESA. But what's nice is that we also have NOAA's Coral Reef Conservation Program. We're set up to work directly with our state and territorial partners to conserve and restore these entities. So we're not 100% reliant just on Section 6 funds to recover corals. And so we've had a nice partnership with protected resources as well as many other parts of NOAA. We were deliberately set up to tap into all of the different capacities that NOAA brings to bear for coral reef conservation. When we first listed the 2 acroporids in the Caribbean and South Florida area, the conventional wisdom on coral reef conservation was to deal with local threats and then to understand what those global threats are and to make sure that we were trying to improve water quality, reduce fishing pressures, reduce land-based sources of pollution in order for corals to be able to adapt to climate change. At that point in time, we were not actively doing a lot of coral reef restoration. But now the science of coral reef restoration has advanced significantly. We are actually now able to work at an individual species level. Before we were just working at ecosystem levels. Anything that we would do would benefit the suite of corals that were in any one ecosystem. But now with advances in coral restoration, again, we can work at that species level. We recently funded a National Academy study on coral interventions. And a lot of the research and then actually implementation of that research now is directly affecting the propagation of outplanted and listed species and working not only with individual species, but being able to identify within those species, which are the more resilient species, which are the ones that we should be breeding and propagating and putting back out onto the reef. Next species or slide. Along the line with more innovative actions and partnerships, NOAA is spearheading a very large effort in the Florida Keys National Marine Sanctuary called Mission Iconic Reefs, where we've taken 7 reefs and have a blueprint of which species, what sort of habitat maintenance do we need to do? What are the grazers that need to happen? And we're going to try to bring those 7 iconic reefs back to a healthy level to where they're performing their ecosystem services as well as they were a couple of decades ago. So that's been an audacious undertaking and working very well. Interestingly enough, one of the largest projects that the US is funding is through DARPA, which is the research agency for DoD. There have 2 pilot projects called the Reef program. One is slated to be in Florida, one will be in Hawaii, and they are creating what they're calling self-healing hybrid biological and engineering reef mimicking structures. And that's really literally for coastal protection and protecting critical infrastructure behind those areas. And they're putting quite a lot of money into it. So it's interesting to see, of all federal agencies, DoD putting the most money into that, because the military well realizes that they've got a lot of assets in areas that are being actively impacted by climate change impacts. Another large effort underway is to deal with an unfortunate epidemic of stony coral tissue loss disease, which happened in Florida and has now spread throughout the entire Caribbean. And the consortia of academics, state and local government, federal agencies, NGOs, and even citizen groups coming together to understand what stony coral tissue loss disease, to get into the water, to actually treat diseased corals, has been unbelievable. And through that effort, we've mounted the South Florida and US coral rescue effort, which has taken vulnerable species out of the water and put them into aquaria all over the United States. We have a really lovely partnership with the Association of Zoos and Aquariums, and they are husbanding these corals so that when we've dealt with the disease, or the disease dies down to some sort of background level, we'll be able to repopulate those lost corals. And that effort has largely been responsible for saving pillar corals. Had we not rescued that, they probably, at least in the Florida Caribbean island areas that has stony coral tissue loss disease, gone down to a population level that wouldn't have allowed for reproduction on their own. If we could go to the next slide. I think this is, yeah, here we go. On the Pacific side, some of our activities, there's just so many more species in the Pacific. So one of the challenges was to even understand, what kind of corals do you have in your waters? What's the population level? How do we even monitor to know if they're rebounding? So we've done a lot of work with the Pacific Island Regional Office and the National Marine Fisheries Service to create Pacific Coral Reef Species Identification Program. And a lot of that will eventually be posted on their website, just so people know what species they're dealing with. We've also worked quite extensively with partners through the U.S. Coral Reef Task Force to create the Manager's Guide to Coral Restoration Planning and Design, and have taken Hawaii and all of the Pacific Island areas or territories through that. And they all now have robust restoration plans and are eligible for funding under that. And we're getting through the Virgin Islands and Puerto Rico now to create their restoration plans. So they've got this viable, robust plan that they've been able to get support through the bipartisan infrastructure law to do large-scale coral reef restoration. And lastly, the U.S. Coral Reef Task Force exists to conserve corals, both in domestic waters, and then to work closely with our partners in the freely associated states. And through the various actions of our steering committee and working groups, we're working across U.S. government and with our partners to achieve conservation gains and to make sure that we're providing technical assistance and capacity to our territorial and state partners to conserve those corals. And just the beauty of the task force to convene and discuss what's necessary for coral conservation immediately lets us tap into and leverage resources outside of NOAA. So corals have a wealth of resources to tap into recovery. Not enough, I think, to actually do it at the scale that we need to do it. But there's a good bit to think that corals maybe have a little bit of a leg up in terms of resources compared to some of the other more endangered and threatened species on the list.
Great, thanks, Jennifer. Let's just transition real quick here to Melissa.
Thanks so much. It's a pleasure to be here today to help celebrate the accomplishments our team has made towards recovering white abalone the first marine invertebrate to be added to the endangered species list in 2001. Next slide, please. The problem for white abalone is that they're delicious, and in the modern era, immigrants to the West Coast enjoyed eating abalone, which developed into a very lucrative industry. Technological advances with fishing methods and a really poor understanding of how to properly manage the fishery led to overexploitation. Next slide, please. White abalone are important members of the temperate kelp forest community, a community that's very productive, can serve as a vital buffer against climate change because kelp absorbs carbon dioxide from seawater and the atmosphere. Abalone help promote kelp diversity because they don't clear cut the forest floor like some other opportunistic species can do. Instead, they open up small patches of the rocky substrate and allow other species of kelp and macroalgae to take hold and grow. And this makes the kelp forest more resilient. As seen in this time-lapse video, adult white abalone stay attached to rocky substrate, grazing on drift kelp, and they don't move very much, so males and females have to be close to one another in order for reproduction to occur successfully. Next slide, please. So the solution to bringing white abalone back from the brink of extinction was outlined in the 2008 NOAA recovery plan for the species. Our recovery team recognized 5 steps to forestall extinction. First, spawn and rear white abalone in captivity. Second, monitor white abalone populations that remained and identify the habitats that they needed to thrive so that when our captive bred white abalone were ready for outplanting, we had identified the appropriate habitats to put them in. Thirdly, we needed to develop methods for outplanting abalone onto native reefs. We did this using other species of non-listed abalone first, so that we could perfect the methods when we were ready for outplanting white abalone. Fourth, we also needed to develop methods for tracking the success of outplanted abalone once they were released onto the reef. And while steps 2 through 4 were going on in the field, back in the lab, the team was working on repeatable and reliable mass production. And we're actually still in this phase right now. Once we get there, we'll be able to carry out step 5 of the plan, which is to engage in large-scale abalone outplanting. And Rachel, if you could just click on the slide, a little animation will occur showing that we want to recover white abalone throughout their range from Point Conception, California to Central Baja California, Mexico. At the center of this strategy was the recognition that data would have to be collected, analyzed, and applied constantly in order to improve the methods for each critical step. Next slide, please. Then in 2015, another landmark occurred when NOAA implemented its Species in the Spotlight initiative to highlight the most at-risk species under NOAA's jurisdiction. This initiative brought greater attention to white abalone and marshaled a lot of resources that have allowed us to implement the recovery strategy that you just saw. Next slide, please. We've made a lot of progress with our captive spawning and rearing program. The number of 1-year-old white abalone in captivity shown on the y-axis has steadily increased since 2012, except during the years of the pandemic. But we project that the number of 1-year-olds will reach about 30,000 this year, and in another year or two, these abalone will be ready for outplanting. Next slide, please. In the field, we've been experimenting with different methods of outplanting white abalone, and here you can see a semi-enclosed module called a short-term abalone fixed enclosure, or SAFE. This module offers protection to our white abalone that are placed inside, allows them an acclimation period before being released into their natural habitat. And to the right of the module, you see in the photograph a time-lapse camera that allows us to capture long-term data that are really difficult to acquire in any other way, such as monitoring predator visitation to the modules over time, before, during, and after stocking. It also can monitor the movement of our white abalone out of the modules during the release phase. Next slide, please. So some results to date. We've had 6 successful white abalone outplanting efforts between 2019 and 2022, and we've outplanted over 10,000 white abalone to native temperate kelp forests. The semi-enclosed module type of method seems to perform best. And we have a minimum of 17% of our abalone surviving based on observations of live animals during scuba monitoring, and a maximum of 61% alive based on mortality estimates for empty shell collections. The truth is probably somewhere in the middle. Also, our mortality estimates have been decreasing with each successive outplanting event, giving us confidence that our methods are working. And the time-lapse cameras are confirming that our methodologies are functioning properly, and thus far have suggested that the modules and the outplanting of the abalone themselves doesn't elicit an atypical community response by predators or competitors. Next slide, please. The future of our outplanting program really rests with understanding what makes abalone reproductive in captivity and climate ready, so that we can ensure these abalone are going to survive once we outplant them. And then we need to increase the production of these abalone. We also need to improve our outplant method efficiencies so that we can broaden our geographic range of outplanting sites. And pictured here, you can see a commercially available outplanting module that we're moving to because it's cheaper, and we can deploy more of them over time. We also want to develop new monitoring tools to track outplant site performance, the survival and growth of our outplanted abalone, and inform future site selection. And shown here, you can see a diver holding an underwater GPS unit, which allows us to map the outplant site and all individuals that we find at the outplant site. And you can also see a photograph of us using underwater photography to take a picture of our outplanted abalone underneath rocks. And then back in the lab, we can use image analysis to get individual demographic information off of those animals. We also are continuing to develop our unified database management system so that we can deliver the highest quality data to the public and to our partners. And we're really excited that we'll be adding the first California island outplant site by 2025. Next slide, please. I think the key to the success of our program is that all of our partners have embraced this definition of collaborative conservation, where each of our partners has a diverse set of knowledge and skills and views, and we've brought this team together to address challenges over time. And in this way, it's given everybody an individual purpose and a greater understanding of how their role serves to meet the broader conservation goals. And next slide, please. Thanks so much for listening. And Rachel, if you could click on the slide, I'd like to thank our partners. Thanks so much.
All right, thank you everyone for your great presentations. We are running slightly behind here. We only have a few minutes left of our session, but we do have a couple of questions in the chat, so I think we'll address those first. The first one here is, when species are classified as endangered, are the other species that they are directly connected with in the endangered species biosphere now monitored or managed?
Dori, I can respond to that. So they don't have a particular status under the Endangered Species Act, but when we list the species, we look at all of the threats. And so if there is something going on with the other species that are directly connected to that endangered species that is impacting the endangered species, that will be evaluated and assessed. We'll look at it in a recovery plan and what actions may need to be taken to deal with what's going on with that related species. When we designate critical habitat, we often include other species as what's considered a physical and biological feature that's essential to their habitat, whether that's a prey species, or for birds, if there's particular species of trees that they need to nest in. And so when you get into interagency consultations, you would be looking at effects that are going on to those directly related species and how that may be impacting the endangered species. And that is the same for any of the Section 10 permitting that I covered. So even though they don't have a formal status, they're not formally monitored or managed, they're certainly looked at if what is happening to those species is directly affecting or indirectly affecting even the listed species.
Great, thank you. We have one more question. I think it's hopefully a quick question from Melissa. regarding the underwater GPS units and whether or not those are commercially available. The person who asked the question says it would be helpful for the use in monitoring their kelp in the Central California region.
They are commercially available through through a company that's based in one of the Scandinavian countries. So if you want to reach out to me directly, I can get you information on how we purchased that equipment.
Great, and that's it for the questions in the chat. And unfortunately, I'm looking at our time and we are near time. So Angie, I'd like to turn to you and see if you can do a quick wrap up for us.
Sure. Thank you, Dori. And thank you to everyone who's joined us today and helping us celebrate the 50th anniversary of the Endangered Species Act. And really appreciate the presentations from Jennifer Koss and from Melissa on some of the really important conservation and recovery work that we've been doing for some of our endangered species. Biodiversity is facing greater challenges than it ever has before, particularly with climate change. But the ESA, in my opinion, is as relevant today as it was 50 years ago. The fact that it contains very strong protections for our species and really at the same time allows for adaptive management, helps us to build partnerships for conservation, can help our species maintain or rebuild resiliency in the face of climate change, and is really critical to ensuring the biodiversity is maintained on our planet in the future. And so I have felt for the last 30 years of my career, I've spent most of it working on the Endangered Species Act, very privileged to be able to be a practitioner and an implementer of this really important conservation statute.
Thank you, Angie. Thank you everyone for attending. We encourage you to scan the QR code you see here on your screen to learn more about how we're celebrating the 50th anniversary of the ESA. And we thank you all for attending today.